Hey, welcome to tutorial 3. So now that we've got an intersection with vehicle inputs and static routes, so we've got our links, our connectors, we have vehicles in our model, we're starting to get into the kind of next steps where we need to start to define like which vehicles have priority over others. To do that, there's a number of objects we can start to use. On the left, we will get into these in I think the next set of tutorials, especially like conflict areas, starting to define some of the other like objects over here. Today we're going to focus on signals. Coding in signals, at least if we do a really simple one for now, which is what we're going to stick to, will allow us to kind of split out at least the east-west and north-south movements, which will already start to help quite a bit with all of the vehicles right now just overlapping everybody. If we were to like run our model, now that I kind of added in the extra like inputs and static routes, obviously we see like there's not a single like rule stopping vehicles from overlap or like kind of driving over one another. So signals will at least start to split out some of the movements and start to work in some of that. So to do that, or to start coding in signals, the way we're going to go about this is two parts. So before we go ahead and start coding the actual network objects that represent signal heads, we actually need to define like a signal controller. So to do that, we're going to open this like signal controller window, and then we're just going to like add a new signal controller. Here we can call this whatever we want. For this, I'll name it a tutorial, like RBC file. Obviously, you probably want to name this the actual intersection, so we can do that. And then we're actually going to select ring varied controller. This is the type of controller that you're going to be dealing with. Used like all over North America. All of the signal timing plans that we typically will like request from the city, they all kind of apply. This is the actual like controller type that they represent. So to code this into our model, we're going to define like a file for it. So we're just going to give like a name to the file. It's going to save it like in the same like folder or directory as our model. So if we hit OK, that should all kind of be set up. We see like a supply file now here. That's the file we just created. And if we want to actually edit that, well, we would select like edit signal groups. Before we do that, we can talk a little bit about what we're actually going to do in terms of like coding this. We're going to keep it really simple. So having a look at just this like PDF. So this is one of the like signal timing manuals we'll send around. We're just going to focus on like two little pages today. First, like just the general kind of numbering of the different movements. So for this intersection, we're going to keep things really simple and code in just like all the movements like at an equal amount, but we will include like the left advanced terms. So we're going to be using all 8 of the like signal phases that you see here. We won't be using like the pedestrian ones for now. And just to kind of explain what a ring varied controller does, it's pretty simple. This is the general like layout of the different signal phases, and then they're split up into the sort of the two like major like directions. So you have like your north-south and then your east-west, and these are divided by like a barrier. So the idea is that signal phases on the left can't cross the barrier and conflict with. So you don't have like conflicting movements happening at the same time. And it's pretty much that simple. Like the signal controller will just kind of run this from left to right and just keep like looping like through that. So it's, I don't know, in our actual like RBC controller in Vissim, we will like define the sequence, and we'll actually like start with that, and then we'll start to put in some actual times for like our different signal phases. So if we like hop back to our model, and if we right click here and we go edit signal groups, a window will pop up. Should be like it should be empty right now. Here let me just make sure that's working. Yeah, so you should be seeing like a window here. And we're gonna start by defining basically our sequence. We'll add in like, we'll really be using the basic timing for now, or the base timing input, so we don't really need any of the detectors. We're going to keep that out of this first signal. So to actually define our sequence, we'll scroll to the bottom and we'll see like a section that says sequence, and here we're just going to define, oh actually before we do that we need to create them up top. So under the base timing we're going to create our eight groups, and then we can go back down to sequence and actually define them here. Yep. And then to add our barriers, just double click above the section, and now we've got the kind of base sequence. We're also going to specify like a pattern, so we'll just set pattern 1 to be the one that the controller actually runs. The idea is that you can set up patterns throughout the day to include like all the different like timing patterns for one intersection. So following that same like kind of map, we're just going to number or just kind of name the movements. So I'm just going to like plug these in really quickly, but basically just giving these a name, either like the left turn or the through. So that should be right. And then from here we're going to define 3 things in this section, in this like area here. We're going to define the like basically the amber and like red clearance, or like yellow and like red time, and then we're also going to define like our max green time. In this case, like we'll enter a min green time, but it won't matter. We're going to run our signal as like a fixed time like signal, so we're going to run just the maximum time. We're not going to code detectors or anything that kind of like allows the signal to vary the times depending on traffic. So for this, for the turns, like we'll just put like 3 seconds yellow, 1 red. This is obviously like varies depending on the intersection, and we typically use like a signal timing plan that we get from the city to actually like create these inputs. But for now, we'll keep this really simple. And here we'll just give like some time to the left, and what I'm trying to get to here is a cycle length, which I can define here for pattern 1. So if you want to actually show pattern 1, you just right click here to show it. I'm going to try to get to like 100 second like cycle length, and once again like that's on the actual timing like pattern that we get, the actual timing like plan. So I've now defined the base times. There's nothing showing up here because we actually have to define our like total split times, but we'll come back to that in a second. We also need to just select 2 like movements here to just to run at like startup. So if we go down to pattern 1, here we're going to just define our split times, and then we should be good. Oh, we also need to define a min green time. I don't know. It's not really important for what we're doing here, because we're going to be these are going to be the times we run. So under pattern 1, the split time is simply the sum of your green plus yellow plus red, so it should be 12 seconds for the turns. And as I plug these in, we should start to see them show up at the bottom, and then the through movements should be 38 seconds. Yeah. So I'm starting to see like our actual timing plan here. And the only thing we need to check off here is I think we need to coordinate 2 of our signal groups, and we're going to select max recall. So this is what makes this like a fixed time signal. It's just going to run the max like green. From there, I think we've got everything we need. So if we hit OK, it's going to save like our file, and we can like run this just to see if we get any like errors. It seems to be okay. It's running the controller, but right now we haven't defined any signals, so there's nothing to really like. The signal controller isn't controlling anything yet. To do that, we're just going to code signal heads. So here, this is kind of back to that point about keeping the connectors just after the like stop bar. We want to put the signals so that they come before the connectors, and then we just want to make sure that like our connectors come after, but the signals themselves are close to that like that actual bar there. And when this opens up, basically the only thing we need to adjust here is like the signal controller and signal group. So this is sort of back to that map. So this one would be 8. Quickly copy these by holding Control and just dragging the object. So I've now made 3. They all have that same parameter. And then for the turn, I'm going to do the same, but I'm actually going to edit this one. So I'm going to change this so that the second or the OR signal group is 1/8, and then the first one is actually the left turn. So in this tutorial, I'll actually just code all the approaches instead of just the one. So we can just keep making our way around. So this should be 6. Copy that to the 3. Make one more copy for this one. And 6. Okay, we'll do this approach next. Same thing. This is 4. I'm going to move this up a little bit. It's a little too close. Okay, so the throughs are good. The right looks okay. And then my left turn. And then once again, this one should be 7, and this is 4. Once you have like more intersections and more signal controls, then that first signal controller value starts to matter a lot more. That's how you basically select which signal controller you want to code this for. Right now we only have the 1, so everything is like 1 dash the value. This one's 2. And this is our last approach. So copy this to these ones. Double check my connectors. This one's a little off, so I'll fix that. And then my left turn, I gotta just change the reference. So this one should be 1.5 and 1.2. Okay, so now we have our signals. We have our signal controller. So if we run our model now, we should see the signals changing based on our signal timing plan, which looks like that's working. Yeah, and we should start to see like our north, south, and east, west like vehicles actually have like signals start to separate those movements. If we want to like preview the signal timing plan or to review, basically under signal controller, under like evaluation and window, you can show like signal times table. You can also right click on the signal controller to show signal times table. This will basically give like a preview of the signal that's running. So we see like all the different movements. We see at the beginning it ran like a pretty weird like signal. Usually the first cycle it's just trying to make like the offset. So we don't really need to worry about the first one, but you see if we use like our quick mode to kind of speed up the simulation quite a bit. You see here like this is the actual cycle that we coded in. You see like our left advances and our through movements and everything looks like it's equal because that's how we just find that. Yeah, that's it for tutorial 3.